Okay, so in this video we're going to look at sine rule, and sine rule is used with non-right angled triangles. Okay, so the minute you spot that you have a non-right angled triangle, you basically only have two options. It's either going to be sine rule or cosine rule. Now I have a whole other video on cosine rule, so do take a look at that. But they are your only options when it comes to non-right angled triangles. It has to be either sine rule or cosine rule. So let's take a look at sine rule, and of course I want to show you exactly how you know to use sine rule and not cosine rule. So the key bits of information that you want to look out for. So sine rule is in your log tables, and this is the way it is written. Okay, I'll just show you where it is here on page 16, right? To see where we have quite clearly a non-right angle triangle. Down here you have the right angle triangles, okay? But with the non-right angle triangles, your two options are sine rule and cosine rule, and here they both are on the one page. So there's sine rule the way it's written in your log tables. Okay, one of the key things that I have written there is with sine rule, you always want to link opposites, okay? And if you can't link opposites, that's how you know not to use it, if you like. If you can't link the opposites, then it's most likely going to be cosine rule. Linking the opposites, so what does that mean? So when they put a little a here, it is representing a length, okay? So it's always the side length divided by sine of its opposite angle. So there's the side length A, and then you would link it in with the sine of its opposite angle. So that's what we mean by linking in the opposites. And that would be equivalent to the other side length, let's call it B, and that would be divided by the sine of its opposite angle. So there's the side length B, and therefore this is the angle opposite that length. Now they've written it out like this in the log tables because they are all equal to each other, but we don't have to fill in kind of three parts to sine rule when we are using it. When we are using it, all we'll do is we'll write it like this. We just need two sets to link up, if you like. We'll write it like this if we're looking for a side. In other words, you'll put the side on the top. Remember, the A and the B represent the side lengths. The angles are on the bottom. But if you're looking for an angle, you can just flip it, okay? And so you could put then the angle on the top, so sine of the angle, divide by, and its opposite side length on the bottom. So it's much easier to do a flip and have all the angles on the top when you are looking for an angle. Okay, so that's useful to know. So that's the way we're going to be writing it out. That's the way it is in the log tables. But if we're looking for a side, we'll write it out like this. And if we're looking for an angle, we'll flip it and write it out like this. Okay, so let's take a look at some examples now and we'll see exactly how this works. Okay, so let's take a look at this example, and we're looking for this side length marked X, okay? If you're feeling confident, why don't you press pause and see how you get on? Otherwise, if you want to wait for the first two steps, maybe just to get a little hint, then you can press pause and see if you can finish it out yourself. So given that I'm looking for a side length, okay, and I can link opposites. So this is what I'm looking out for. I can link that with that, and I can link that with that. So I can link opposites, and when I link opposites, I only have one thing that I don't know. So I've only one unknown, one thing that I'm looking for. I have all the other pieces of information, all right? So that's key. So that's how I know I can use sine rule. And since I'm looking for a side length, I'm going to write sine rule out like this. And now I'm going to fill it in. So what are we looking for? That's probably the easiest thing to fill in first on the left hand side. So I'm looking for X, and it's a side length, so I can put it in on top. And always we are linking opposites, so what needs to go underneath is sine of its opposite angle. So the opposite angle to X, of course, is 62. So that's got to be sine 62. Equals, and then we have any other side divided by sine of its opposite angle. And so the other side length I have in this example is 12, and I can link it with its opposite angle, 34. So it's going to be divide by sine 34 degrees. Okay, so now always what you want to do, of course, is get X on its own. But in order to get X on its own, we're going to have to get rid of this divide by sine 62. Well, how to get rid of a divide by sine 62 is to, of course, just multiply by sine 62. If I multiply the left-hand side by sine 62, it will automatically get rid of the divide by sine 62. But of course, if I multiply the left-hand side by sine 62, I've got to multiply the right-hand side by sine 62 as well. So now I have x on its own, which is exactly what I want on the left-hand side, and on the right-hand side, I have this calculation. And I'm going to put all of that into the calculator now. So let's take a look. Let's put up our fraction boxes. 12 on the top over sine 34, close the bracket, come over to the side with your arrow button, press times, and then I'm going to put in sine 62 and close the bracket. So I have it exactly as I have it written here, and press equals, and I'm getting 18.9476. Let's do 2 decimal places here. Well, that would be 18.94, but remember you've always got to look at the number after, which is a 7. 7 is going to bump up that 4, of course, to a 5. So 18.95, and don't forget it's centimeters. That's the length of side x. Okay, so take a look at this example here. So straight away we spot we have a non-right angle triangle. So you have only 2 options with a non-right angle triangle. Remember, it's either sine rule or cosine rule. So what I'm going to try and do is I'm going to try and link the opposites. And if I can link up the opposites, then I know that I can do sine rule. And I can link up the opposites quite nicely there. And the only thing I don't know this time is the angle x. I have all the other pieces of information. Okay, so now that I've figured out sine rule, the other thing I want to be careful of is, am I looking for a side or am I looking for an angle? Now, in this one, I'm looking for an angle. So the way I'm going to write sine rule out for myself is to write the angle first. So sine A over A. So remember, you're going to flip what's in the log tables. So sine A over A is equal to, of course, sine B over B. All right, so remember, this is the way it is in the log tables. Okay, but what I could do, you never need all 3, remember, you're only ever going to really deal with 2 of them. But what I'm going to do is I'm going to flip it to put the angles on the top whenever I'm looking for an angle. Okay, that will make my life a lot easier. Right, let's fill in the piece of information. So let's put the one we're looking for in here. So we'll put sine of the angle x over, and of course its opposite side must go in on the bottom. So that's 14. And the other angle that I have, of course, is 53. So fill that in, sine 53. Over its opposite side, of course, is 12. So there we go, we have it filled in. Now, a little bit more manipulation on this one, because obviously I want the angle x on its own. But before I can do that, I'll have to get sine x on its own first. Then I'll be able to get x, the angle, on its own. So in order to get sine x on its own first, I want to get rid of this divide by 14 on the left-hand side. So if I want to get rid of divide by 14, I'll just multiply by it. Multiplying by 14 will cancel out with the divide by 14 or get rid of it, and that will give me sine x on its own, which is exactly what I want. But of course, if I multiply the left-hand side by 14, I've got to multiply the right-hand side by 14 as well. So on the left-hand side, I'm left with the sine x, as I said, which is what I want. And on the right-hand side, I'm left with sine 53 over 12 times 14. And this is what I'm going to do on the calculator. So get your fraction button up, sine 53, close the bracket, over 12 times 14 equals 0.9317. Okay, here's what I'm going to do. I don't want to round too early in the question, okay? So I'm not going to round at this point. I'm not at my final step yet. So what I'm going to do to make sure I have full accuracy, I'm going to write out the whole thing. So 0.9317414284. And now I'm going to be able to find x on its own. So do we remember with our trigonometry from Junior Cert, what you do on the calculator to get the angle whenever you are looking for the angle? Or in other words, how to undo the sign to get the x on its own. How will we undo the sign to get the x on its own? Well, what we're going to do is we're going to do sine inverse. So we're going to do sine inverse of this. just write it all out. I still have it up on the calculator display here, because what I'm going to do to get sine inverse, do we remember we have to press shift sine, so press shift sine, so there's sine inverse coming up, and I'm just going to press answer down here because that will put in there the previous answer that I had on the display, close the bracket, equals, and there we go, there's my angle. So 68.7079, I'll do 2 decimal places, so 68.70, look at the number after always, that's a 7, that means it's going to make the 0 bump up. So I'm going to end up with 68.71 degrees. Okay, let's take a look at this example here. If you're feeling confident, press pause. If you'd like just maybe the first or second little step to know the direction that you're going in, then you can have a look at that and then press pause and see if you can finish it off yourself, which would be a good approach to practice some parts on your own. So, we have a non-right angle triangle. So you've only got 2 options, remember, sine rule or cosine rule. So let's first of all see, can we use sine rule? So sine rule, remember, is all about linking the opposites. So I can link the opposites here, but I can't quite link the opposites here, because if I'm using x, I will need its opposite angle, which is here. Now the interesting thing is I do have the other angle in the triangle. So, although I'm not given the opposites explicitly, I am given enough information that I could figure out the third angle in that triangle, because if I have the other 2 angles, I know, of course, that the 3 angles in any triangle add up to 180. So I can figure out this angle, and then I will have the opposites linked up, and so I will be able to use sine rule. So, in other words, this angle here must be, well, if I take away 92 and 26 from 180, I get 62, and that must be that angle there. Now I have the opposites linked up, and of course I'm looking for the side, so the way I'm going to write out sine rule for myself is A over sine A equals B over sine B. Okay, and let's start inputting now. So I'm looking for x, so let's put that on the top. And of course, I will divide by the sine of its opposite angle, which is, of course, 62. And then I have another side length. The other side length I have, of course, is 14. That's the one I want to use. Over its opposite angle, or sine of its opposite angle, should I say. So sine 26 degrees. There we go. Right, now let's try and get x on its own. Well, the only way to get x on its own is to get rid of the divide by sine 62. And how to get rid of divide by sine 62 is, of course, to multiply by sine 62. That will cancel out the division. But of course, if I multiply the left-hand side by sine 62, I've got to multiply the right-hand side by sine 62. And that will give me the x on its own, which is exactly what I want. And 14 divided by sine 26 times sine 62 on the right hand side. So let's do that on the calculators. So putting 14 on the top, of course, and then sine 26 in brackets times sine 62, close the bracket and press equals. And I'm getting 28.19817. Let's do to 2 decimal places, 28.19, look at the number after. 8 is going to make the 9 bump up. And then that's going to have a knock-on effect because the 9 will turn into 10 and then that 1 will be carried over to there. So what I will end up with to 2 decimal places, 28.20, and don't forget your units, centimetres. Okay, last example. Take a look at this question. Why don't you press pause and see how far you can get on your own on this one, and then you can press play for the solution. So this time I'm looking for an angle. I have a non-right angled triangle here, of course. I want to see, can I link opposites to see if I can use sine rule? And I can quite nicely link up those opposites. So I will use sine rule. Given that I'm looking for an angle, I want to put the angle first. So I'll put sine A, of course, over A is equal to sine B over B. There we go. So let's fill this in. So I'm looking for x, so sine of x over, then divide by its opposite length, which is 10, is equal to sine of the other angle, and the other angle here is 35, divide by its opposite side, which is 12. So there we go. I want to get x on its own, but of course this one's a bit trickier. I'll have to get sine x on its own first before I can get x, the angle, on its own. So in order to get sine x on its own, I'll want to get rid of the divide by 10. So I'll multiply by 10. That will get rid of that. But of course, if I multiply the left-hand side by 10, I've got to multiply the right-hand side by 10. So that leaves me with sine x is equal to, and then I have sine 35 degrees over 12 times 10 on the right-hand side. So let's have a look at this. We're going to do all of this on the calculator. So sine 35 on the top over 12 on the bottom, and then multiplied by 10. And that gives me this. Now again, I'm not finished, so I'm not going to go ahead and round just yet. So I'm going to write that out for myself. So I have sine x on the left-hand side equals, and then I have 0.4779803636. And of course, to get the angle now, whenever you're looking for the angle, in other words, undoing the sine, we do, of course, sine inverse. All right, so I still have that up on my calculator display, so I'm going to leave it there. I'm going to press Shift Sine to get sine inverse up, and then I'm going to press Answer, and the previous answer is going to be inputted there for me, which is exactly what I want. It saves me typing it all out again. Press equals, and there we go. Let's do 2 decimal places again, 28.55. Look at the number after. 3 doesn't make the 5 bump up, so the angle is 28.55 degrees.